What's up, YouTube? In this video, we're going to be looking at SignalR. This is effectively part 2 of this series. Part 1 was mainly on WebSockets and TCP, HTTP. This is more on SignalR, but it's more like the getting started version. By the end of this video, I want you to be able to get up and running with SignalR and have a basic understanding of just some communication that happens and how to make that happen between a browser and your server side back and forth, or maybe just in one direction. But there are going to be 4 parts to this series. So the diagram I show you today is sort of the full-fledged version of the application. I'll describe the whole application and then I'll tell you what we're going to be doing in today's video. And then on November 14th, mark that date, November 14th, I plan to have a live session. I will provide details of that. It's going to be at 9:30 EST, Eastern Standard Time, 9:30 a.m. EST. I'll give you more details and I'll also come back and modify the descriptions of these videos till the videos I make on November 14th. So on November 14th, I think that's another Saturday. Today is Saturday. So then rather than me recording another video, we're going to have a live session. And during the live session, we're going to develop an application that's going to be using SignalR, WebSockets, AMQP, and so on and so forth. So if you're interested in that whole effort, please be sure to join the live session on November 14th. The more details would be available when I'm ready with that information through that YouTube community thing. And I see the YouTube community post. I don't know how you guys see it. And also I'll come back and modify the descriptions of these videos in case you're watching this after the fact and you want to go back and check it out. So I'll update the descriptions. All right, so let's look at what we are going to be doing as a whole, and then I'll drill down into what we're going to be doing in this video, and then we're going to start with the actual coding. All right. Okay. All right. So what you see here is, let me just change my cursor pointer. This is a regular or standard ASP.NET Core SignalR. By the way, this video or the code we talk about here is very specific to ASP.NET or .NET Core 3.1. There have been quite a few changes in SignalR over the period of time, .NET Core's lifetime, but also there are quite a few changes between .NET frameworks, SignalR. I'm talking about in terms of the libraries, right? So the compatibility and stuff like that. Conceptually, nothing has changed, just libraries will change. So if you are wanting to follow along, then make sure you're using .NET Core 3.1. Even if you don't use it at work, it doesn't really matter. You can still use it for yourselves. And you probably should if you're not already doing that at work. Start playing with the newer versions. And I guess in November, .NET 5 is going to be available. You want to start playing with that too if you haven't already started playing with that. Anyway, so this is .NET Core 3.1. All right, so this is a regular ASP.NET Core SignalR application. We'll be building this application, the starting of this application in this episode here. But in the final version of this application, for example, there will be an application here that's using WebSockets to talk to different clients. We'll be building browser-based clients. And if the coding is done correctly, it'll also work on phones. So it shouldn't really matter what the client is. We're also going to be building in the final version a .NET Core SignalR client. So instead of a browser, we'll be building a client. But in today's video, we're going to be building the browser version of it in the next video. So today we build the basic SignalR application, get it all working between browser and server, hook up all the stuff, and kind of leave it there. In the next version, part 2 or part 3, we'll be doing this. We will then modify the code we've written here to then support being a subscriber to a message broker queue topic, whatever you want to call that. And we could use either RabbitMQ or Service Bus here. And then we could have an application or a device, depending, maybe we build this application ourselves on the November 14th live session. I have a device, but either ways, it could just be another application that is a subscriber and a publisher to the same broker, all right? So let's assume, for whatever reason, this application is publishing messages at a regular frequency. We want those messages to be subscribed to by our ASP.NET Core application. And then that's using AMQPS as a protocol, of course. And then that needs to sort of translate that to the WebSocket protocol using our code here, the application here. And then that should translate to WebSockets, and therefore we should be able to see the same data in a browser or another .NET client, .NET Core client application, like a desktop application. So the idea is that messages that come from some device or some other application through a message broker of some sort, RabbitMQ service bus, can be received by our ASP.NET application. So that's following the AMQP or AMQPS protocol. And our ASP.NET application can then translate that data into publishing or broadcasting that data to various WebSocket clients, any number of these guys. And of course, it's all cross-platform, including the client core, which is .NET Core. Okay, so and then eventually, what we will do is we will have a button or something on the client side that allows us to publish a message back to the server side that then publishes a message to the RabbitMQ broker that then publishes a message to the device or whatever else is on this end. And the idea is that you might have, let's say, a start button on your browser that using WebSockets talks back to your WebSocket side of the application here, which then publishes a message using MQPS to your broker. And then that broker, the subscriber here, this device or application here, the subscriber to that message receives it, says, oh, you want me to start? I'm going to start. And when it starts, that's when the messages start to sort of pour out of this application. Okay, hope that makes sense. Hope this is also exciting. I love this idea of different applications, different platforms, different sizes, devices, protocols, all working seamlessly without kind of too much headache, right? That's the beauty of this. And then I thought a long time about building the SignalR kind of video, but it's like always a chat application. I got so sick and tired. First of all, I wasn't building one, and there are many YouTube videos, I'm sure, and blog posts, including Microsoft's own articles. So I wanted to build something or provide you guys with something more, at least for me, more real world. I mean, when was the last time I built a chat application, right? But also something that is fairly, so you can do all of this on your local machine if you have to, so don't get concerned about message brokers and service bus. If I say service bus, you can assume that's RabbitMQ because you can do that all on your local machine. So I'm hoping you try these things, and I hope you have your own sort of setup and you build up this application as the series goes along. And then on the 14th of November, when we have our live session, you'll build another few components. At that point, whoever's online can start receiving and receiving messages from everyone else or something. We'll have to organize that a little bit, but that's the idea. All right. Okay. So now let's look at the code. .NET Core. So what I have is just I'm starting with an ASP.NET Core web application, and whatever, it doesn't matter, though maybe I should name it something. SignalR getting started. Okay, so we start with the web application, not a web API application, and it's .NET Core and 3.1. Okay. All right. So this is, at this point, it's just a normal ASP.NET Core application. What we're going to do here is we're going to include, so remember this is SignalR, so there's libraries required on the server side, meaning the code that we're going to write in C#. There are also libraries going to be required on the client side, the browser, JavaScript libraries. So we need both of them because eventually we want both browser and the server to be able to talk SignalR. So let's first look at the pages here. So this index page here, as we have it normally, this is the page we're going to be modifying because that's like the home page, if you will. We don't need some of the stuff. We'll remove that and we'll modify it to include some of these elements that we need, as well as include the JavaScript here, the JavaScript that pertains to SignalR, right? And then in our application, startup, we'll configure, or we can do it now. So I don't know, this is big enough. Okay. So in the configure services section, you can add your services.add SignalR. And there are some arguments here, namely, I think it's options, hub options if you want. You can take a look at that. In fact, I might suggest that you do that anyways, because there are some issues with SignalR. Not issues, I just don't understand why they designed it like this. You don't see problems unless you use logging. And I think that's a terrible idea. I mean, I might decide to log an exception, but I certainly want to see them and not have them be seen and discover the problems only if I start logging the application. So that's unfortunate. I've had a few experiences with that with SignalR, where the exceptions just are only visible in the logging side. They're not. You don't see anything happening on your C# side, so you don't know there's a problem until you start to log. So I suggest, at least when you're learning and hooking things up, start the logging, and debug, and then if you see a problem, at least you can see it in the logs. So the way you do that over here would be hub options. And it's not anything to do with SignalR. This is simply, this is wrong. This is the hub option, not configuration options. I do want to enable detail errors. So that's what I want to do over here. And we'll get to the configuration part at a later point, but right now just turn this on. It's not required that you turn on detail errors, but I'm suggesting you do that initially. Maybe in production you want to turn that off. Okay, then the other thing over here is we would have to use or map in our endpoint section here, map the hub. In SignalR we have this notion of hubs or a hub, and so when we do the map hub, it's going to need a type or a class, just like we have with configure services. It needs a class, so we're going to have to define that class. So let's do that. So over here we'll add a new folder called hubs. Not that we plan to have too many of those. And of this hub we'll have a class called MessageBroker hub. And this class descends from another class called hub, which is the base class of all hubs. And that class is in SignalR. So it's now adding on. I haven't included the library, the SignalR library, but it's going to do that, I'm guessing, here. Right. So that we actually added the dependency all by itself. Let me just verify that. Yeah, how to do that? Okay, we might as well do that. Let's add the SignalR. That one, ASP.core SignalR. Okay, so I'm not sure what the difference between Microsoft.asp.net core SignalR. Okay, and let's include that. Okay, so here we have our message broker hub, right? And when we map this hub, it's going to require the pattern or the path, if you will. So let's call this message broker, right? And then there's another option here to provide the hub options, and this is where you can control or configure the hub. It's got a bunch of other options like how long to connect or retry intervals and stuff like that. So that if you ever get to the point where you need to tweak those, then you can do that over here. I personally won't touch anything right off the bat. As you start working with things, maybe you find some difficulty, and then you might want to look at some of these options in case those might be relevant to you, right? Okay, so what have we done so far? We've simply added the service, the SignalR to the services, and we mapped the hub to that path, which means any requests that come to that path will be mapped to our hub, this hub here. Now, in this application, given what we're doing today, we don't have to do anything on this hub. That's it. In the next one, we'll modify the hub. We'll add a few methods to it so we can get from this client side, we can talk to the server to this hub here. Currently, or today's version, we are talking from here, from the server side to the browser side. So we're not doing the browser to server side. So we don't need to actually modify or write any methods here. We are effectively calling methods on this class, except we're not doing it from the class, if that makes sense. Okay, and I want to also show you kind of like a best practice of how you should do this sort of thing. I see a lot of examples on blogs and videos and stuff, but they don't give you the real way to write code. And I don't think that the code that they show you in those blogs and stuff is the right way to do it. So in these videos, I'm going to show you some of the, let's call them the best practices of how you should actually write code for real world applications that relate to or are using SignalR and background services or worker services. So in today's video, we're going to be using worker services along with SignalR, and I want to show you how do you do that? How do you make these two things talk together? Because they're actually quite separate. And if you followed along with the normal examples, you'll never get there. And if you did, you were going to hack it, and I didn't want people to do that. So for today, nothing to be modified in this class. Okay, now that we've done sort of this server side of things, let's implement or add on, include, download the client side of things. So now over here, I don't know what the client side library, that's what it's called. I just do L, but yeah, client side library. So you're adding a client side library, and here you want to pick the unpack provider, and then at Microsoft SignalR, and that's the SignalR client side libraries you want. You don't want to specify it to the or fix it to the this one. You want to just say latest, that, and you want to choose specific files, and then you want to go into that. So basically, you want these SignalR related files, and you also include the map, because of course if you're doing some debugging, you want the map files there, or if you're using TypeScript, you can do the same. Okay, so, and then, here, I forgot to see I don't want the Microsoft, so I'm basically telling it to download it to the lib folder, but SignalR and then that. But that's going to be quite a deep, anyway, it doesn't matter. Okay, so at this point, it has put in, yeah, so it added the lib SignalR, that's what it did. It added these files here. Okay, so then in our index.cshtml, we need a script tag. Source for that is going to be lib/SignalR/list browser. That. Okay. All right. So that's taking care of the SignalR framework, or the ability for the browser to be able to communicate using SignalR back to the server, and for the server to talk to the client. There's none of our JavaScript in here. It's just the library JavaScript. Okay, so that's hooked up. We can also do here, for example, we can take this out, and we can say we don't need that. Okay. And we probably want to also just modify the layout page here. Yeah. Okay. Let's just see what that looks like. Okay, so far so good. All right, so what we are going to be doing now, just to give you, now that we got the basic thing set up, right? There's the plumbing, if you will, SignalR plumbing. You probably don't know if it's working, but we'll look at that. We're going to be, the application is going to have a worker service that's going to publish messages using SignalR to the clients, right? in the final version, those messages will not be self-published, if you will. They will come from that other application that's going to come through message broker and then into the worker service, and then from worker service to SignalR and then to the browser. But for today, we're just doing the browser part of a server-side part of things, where our worker service will itself be generating messages every second or whatever the interval is, and we want to receive those messages on the browser and see them appearing here and do a little bit of the display aspect of that. Okay, so that's all we're going to be doing today, but we're going to have this whole thing hooked up. I'm going to talk about some of this stuff you might see in the debugger and DevTools on the browser, and some things about the protocol, serialization, deserialization. Okay, so now that we have this done, the idea is that when we receive messages, we want to be able to sort of push them into, or fill up, let's say, a div. I'm going to call this messages, and our JavaScript is going to say, please add whatever messages you get into this div being the container for all those messages. That's what that is. Okay, and our JavaScript, we will probably add a JavaScript file here that will be our JavaScript. Add new item. Okay, yeah, same shortcut. Control-Shift-A. Okay. All right. We're going to call this MessageBroker.js. And then this file also needs to be included in this index.js. So here we can also include the script tag for our JavaScript, which is here, and that one. Okay. And then go back to our JavaScript file here. Now here we need to write some JavaScript. There you go. So what I've done here, I'm using the SignalR hub from our SignalR library, and that's the instance or reference to that. We are using the same path that we registered here in our server-side application. Oops, sorry, we issue the startup. With that, it has to be matching, not necessarily case sensitive. I don't think. I think it normalizes it to lowercase, but it has to match that. And so what we've done in our index is in our JavaScript file, we're saying we need a hub connection to that. We build it. Now we have a connection, and then on the connection we have to say start. And when we say start, we may get an exception, so we cache that exception here. But if not, we're just simply going to write to the console saying the hub is connected. So if in our browser's DevTools console we see SignalR hub is connected, it means it has found that hub that is sort of listening, if you will, on that port or that path. And the negotiation we talked about in the previous version, from HTTP upgrading to WebSockets and the handshake and all that, that's all taken place and it's connected. All right, so let's check that out, make sure that that's actually working. Open up the DevTools, look at the console, and you can see that SignalR hub connected. So at least we have that kind of all wired in. Okay, now the next is to start publishing these messages on a timely fashion. So what we need is, first of all, somewhere in our server-side application, we need a reference to the hub. So far we've kind of added the map hub thing, but that's all we have about the hub. When we got a class, we never created an instance of it. Should we add it to dependency injection in ASP.NET Core? Like, how do we get an access or reference to that instance? Do we create our own instance so we can publish messages to all clients, if you will? If there are multiple browsers that are connected to that server, how do we get access to the hub? Okay, that becomes kind of confusing. So in SignalR, in this implementation for .NET Core, you don't need to hook up or register that hub class with dependency injection. It is available, but you don't have to do it simply by adding SignalR and then registering the hub in the endpoints. It creates an instance and it's registered with dependency injection. So what you want is, let's do that. So what I'm going to do now I'm going to add, let's add the worker service first. So let's call it worker services. And to this worker service, message broker pub sub worker. Okay. Now, if you remember, this class needs to descend from, I think it's called background service, or the background worker. No, hosting, that one, background service. And then this class in turn needs to implement that. Okay. I'm just going to seal this class, sealed. Okay. So in fact, I should probably go seal the hub as well. Okay. Let's go into our hub and seal that also. Okay. So now here, what we're going to do is we're going to just iterate over this while not stopping token dot this cancellation requested, some sort of a loop here. Every second, and we need to mark this with the async modifier since we want to await that. Okay, now this is the loop, but every iteration here we want to publish and data to our clients, the SignalR clients. Okay, they will work on the actual data and all that, but just conceptually, I want you to understand this. I'm going to hook this up, wire this up, and then I'm just going to write the code myself, and then you'll just see the final code. But I want you to see the whole process of getting this whole thing hooked up first, and then the actual data that's being published. I'll just show you the code. All right. Okay. So I said the hub. This hub is available to us through dependency injection. So what we're going to do is we're going to modify our message broker publisher worker constructor to use the IHubContext of our message broker hub. Okay. Message broker hub context. We'll just assign it to a private member, private read-only member, which I also generate here. Okay, so now that we've defined that private read-only member, we have access to it over here. So what's going to happen in this code is here, we're going to reference it, and we can get access to the clients. So this is all the clients that are connected to this hub. The hubs are fairly complicated, not complicated. They have a lot of features. They have things like clients you can connect to or publish messages to individual clients. You can find them by ID. You can find them by user. There is notion of groups in hubs. You can have groups of people or groups of clients. So it can get fairly capable. I've never had a need or seen a need for that sort of thing, but I'm guessing there's someone who has some needs like that, which is why they may put that in there. So you might have to, if you want to separate out different groups of people, you can do that with the hub, with the context, with the help of the features that are there. We are going to just use clients and all clients. Okay. So clients.allClients, all. And we want to send messages to all clients. So every second, we want to send messages to all clients. Now, these are clients that come and go. So the way SignalR is implemented is you might have 2-3 browsers that you open on your desktop. So there are 3 clients, and you can join and leave as you want. And if you join, you'll only see messages since you join, not like the whole history, right? So you obviously won't see all the messages that occurred before you joined that chat or that hub. But SignalR is fairly robust in that whole aspect of clients joining up and leaving and joining and leaving and all that. So you're not have to concerned with the actual connections and TCP aspects. The library takes care of that. So here we're going to just send an asynchronous message to, and if you look at the signature here, it's requiring a string method name and then a cancellation token. There are many overloads. There are 11 overloads, as you can see here. But I just want to show you that they're saying send a message to all the clients to where exactly. And because we're dealing with JavaScript, the method name itself is in the form of a string. Right? And then the rest of it, now there are multiple overloads, as you can see here. There's a cancellation token, but you have other overloads that take one object or one argument as an object, 2 arguments, and up to like 10 overloads. So essentially what you're saying is you're identifying the JavaScript method name, the method of your JavaScript method, the callback, if you will, the subscriber on the JavaScript side in the form of a string. And again, I don't know if they're case insensitive or not, but JavaScript is. But I think the SignalR library does a lot of this munging up of cases. So now it gets very confusing as to, because it doesn't do it all the time. So it's very difficult to tell, okay, why did they do it here but not there? And so there are a few new nuances, so I forget. So I use the same casing. I don't worry about relying on my memory. So I just say, if I name this method here like this, I'm going to call it the same thing over there. So because this is a JavaScript method, I should be using JavaScript conventions for method names, which would be camel cased. So whatever I do here, it'll be a camel cased thing. So it'll be on message received. And then we'll have a class called event message. So we're just going to send that event message DTO across. And then on the JavaScript side, we want to be able to see it and extract the parts and the pieces and display it correctly and cleanly. So that's what we want to do today. That's it. Right. So now that we know how to get access to our hub context and then our clients and send all messages to our clients. And here we want the event thing. I'm going to now just write the code myself here, and then we'll be back and I'll explain what I've just written so far so you can see how that's done. All right. So what I've done is I've defined a event message DTO type. It's nothing special, just a standard immutable DTO. It's got these 3 properties, and then initialize the constructor, and that's that. And then I just add some random values. I create an instance for every iteration through this loop. I create an instance of that, assign some good values. And so I know this one is the title underscore, that's the, ID underscore, title underscore with a good, and then a date time. And then I publish that message. Oh, what the hell did that change here? As the parameter. And then I'm just passing the cancellation token in case the library here, the C# library, wants to use that cancellation token also to shut down any services. So which is the same cancellation token from here. Okay, so now we need a JavaScript method on the JavaScript side, and we'll have to register that with our SignalR client connection on the JavaScript side, and then tell it, hey, when somebody calls this method, do that. Right? Then we can receive the messages over there. But without doing that as well, since we have connected to the hub, we can simply see if there's any kind of data arriving. And if there is, or maybe let's do the event, subscribe to that event on the client side, and then look at that kind of the raw data in a console log and then improve on that. All right. So in our message broker JS file, we need to add and essentially subscribe to that method. So we say SignalR connection.on, and we use the same string name that we had in our server side. And it's nothing but a function that takes this one argument. We're calling it event message. And when that occurs, we'll show here. So here we could, for now, just do a console.log to make sure we're receiving messages. We're not necessarily what the message is. We can obviously type this in, but it's not going to be able to show us much. Anyway, so the idea is, since we have subscribed to that event, we should be able to see the result happening here. If this fires and it works, then we know we're kind of on the right track, right? We need also a, all right, that's that. So now if I run this application, it's publishing. And also look at the log. I mean, not publishing. Let's make sure we now actually looked at the worker service. Oh, we never hooked up the worker service. How would we publish it? Okay, so the worker service was not configured, if you will, with the like a hosting service. We need to add that to ASP.NET. So this worker service actually starts up, and then it'll kick in that thing every 1 second. All right. Okay, so let's look at that. So that we need to go to our startup, and over here we'll add services dot add hosted service message broker pub sub worker. Okay. And again, there's other options here, the overloads, where you can provide options. So, but for now we just need that. All right. So now that the worker service is registered, it's actually going to start. And once it starts, it's going to call that execute async method. That's then got a loop that's going to publish messages every 1 second. And now you should hopefully see that. Open the debugger. There you are. So we're seeing the messages coming in here. That's not an error, by the way. It's just highlighting that in that. But we're seeing this kind of the raw data in many ways. And you can see that's the GUID for the ID, the title, the created date, and so on. So we're seeing the messages, which means for the most part, the hookup between the client side, server side has been done. The JavaScript parts that we've written so far are working. And now it's a matter of improving on the displaying of this data. We're not displaying it anywhere right now. It's just doing a console.log, improving on that, and then having it seen in the browser itself. Right. So again, I'm going to just write that code a little bit, and then I'll show you and I'll explain the code. It's pretty simple code, nothing spectacular. So it's just a matter of extracting the data from the event and publishing it. All right. Okay. So back to the JavaScript file. Yeah. I've declared a message count variable, and that we keep incrementing each time this event occurs. We just count the number of messages. We have the message count element that we probably want to put in our index HTML. And we also have a messages element. So let's get the message count element from our index HTML. I don't know if it's there. Okay, we'll put that in here as a, you can put it in here, centered div. Oops. Oh. And here are messages div, so that part is done. Right? And then once we find those elements, we add dynamically based on the event messages properties here. We iterate through all the properties. For every property, we create another div tag, do some styling, and then add that div tag to the li. So this is really going in like an UL li kind of thing. It's all dynamic, so it's very simple code. And finally, we continue to scroll the browser to the bottom. As we add more messages, we want to just make sure the browser is always focused on the bottommost one, the newest one, right? Okay. So let's start this up. And there you go. So the count here is showing us 1, 2, 3, 4. It's increasing, but each one over here is also using the count for the display. And that's the data. So this is showing you the SignalR thing with one browser. Let's open up another tab. If you wanted to do that way, you can see that. Oops. So now there's 2 clients, because there could be 3 clients. We can also use open Explorer and others. 3 clients here. They're receiving messages at the same time. Of course, their counts are very different, but they're receiving messages at the same time. And so if you were with me on this live session, you'd be seeing these messages appear too, on your browser. But now I want to just show you a little bit on the WebSocket side and in the browser, right? We go back to our console thing here. Okay, better stop that console part. I want to show you on the network side. So what happens here is that even though this is going on, we can see on the network there's no other traffic going on here besides the original traffic that came when we first started up. Come on. Okay. When we first started up. So as you're seeing data still coming in here, there's no new network traffic occurring besides the one that we have for the message broker here. And this is, you can see some of it is like the original request itself. We first asked for the request and it said, I wanted to do the upgrade to WebSockets. And then the server said, yeah, let's go ahead and kind of do that. And then the server sent back a 101 to say switch the switching protocols. Okay, so that was the original request response kind of going through from the start. But from that point forward, nothing really has happened. And what you're going to see here now is that here, every time there's a message here, you're seeing the data here. You'll see some of the raw data here. It's fairly JSON in this case. So, and the other thing you can see, I'll make this bigger, is the bytes, the size. And as you can see, it's JSON, which is not the best way to send data. It's okay for smaller applications. It's okay when you have fewer people expected to be online at the same time. It's okay if the amount of data that you're sending is very, very small. But personally, I would not use JSON for this sort of thing. For development, at the time of development, you might want to do that, using the raw JSON serialization. But in SignalR.NET Core, there is support for another protocol called MessagePack. So we have many ways to serialize data, right? We have binary, JSON, XML. Then we have BSON. I'm just pulling out some of the more common ones. BSON, I think, is MongoDB's version of serializing JSON, binary serialization. It's not a full parity or full compatibility with JSON. There are some data types that JSON does not have that BSON has and so on. It's mainly suited for actual binary information such as images and files and stuff like that. All right, but nonetheless, that's an option. We also have, not in SignalR world, but we have gRPC that uses its own binary serialization form, which is very, very small. And then there's MessagePack, which is mainly made for JSON and not JSON, I shouldn't say JSON, but SignalR WebSockets and that sort of thing. So with SignalR.NET Core SignalR, we have the option to flip the protocol to use MessagePack to now it goes as binary. MessagePack is it's probably the fastest serialization we have so far. It's probably neck and neck with gRPC protobufs. And it's about 20%, 25% smaller in terms of the data being sent across the wire, but it's also much faster in terms of the work or effort required to serialize and deserialize. So you get less bandwidth utilized across the wire. It's just a wire protocol, right? So it's just between the server side and the client side. On your JavaScript side, the code is the same. And on the server side, the code is still the same. There's no change there. It's just the configs that you have to do. You have to add NuGets and all that. I won't go through that. There are quite a few quirks there. There are bits of incompatibility there with regards to your data types and such. So I don't want to get all that confused right now. So there's enough documentation on it because of the fact that there are some quirks to it. All right. So in this video, we have looked at this application so far. We're going to be extending this in the next two parts, where we'll add on more functionality for the server side that receives the messages from the brokers, and then have the browser trigger that other applications, and then also build the third one will be the .NET Core client application. That's a SignalR client application. And maybe when I do the gRPC thing in another video some point later, we could use the same application and extend gRPC conversations. So then we are supporting WebSockets, AMQP, and protobufs, so gRPC, and have clients and servers of both these kind of all just talk to each other. Maybe that'll be a nice mess to have. I'm hoping to see you all on the November 14th at 9:30 EST. The time is there, the date is there. I'll give you more information through the next videos, and then of course the description of this video itself I'll come and modify. So in case it's number 13th and you want to know what to do tomorrow, you can come back to the description of the video and look for more details on where and how, but most likely it'll be Skype or Microsoft Teams. I've used Skype, as you know, before, Microsoft Teams, or my community post thing, however you get access to that. If you're not a subscriber, please subscribe. If you have not notified yet, please notify. Please hit the notify button. Please hit the notify button. That way you'll be notified, as when I publish my community posts and all that there. And I hope you've enjoyed this video. If you have, please give me a thumbs up, and I shall see you next time.